All right, I'm gonna go ahead and get started. Before we jump in, if you haven't turned in the link to your GitHub project from last week, make sure you do that, and make sure you go out and take the quiz as well. Let's see, for this week, look at the old syllabus. We're going to be talking about data frames and using pandas for that. I am going to change up this course schedule just a little bit, and I'll send you guys an announcement and I'll update the syllabus. Basically this week 9, which is Streamlit, I'm going to move that up here to week 6 and just shift everything else down. So this mini project 4 will actually go with next week's Streamlit. After kind of laying everything out, it makes a whole lot more sense if I do it in that fashion for you. So, all right. So today, pandas. No, not that kind of pandas. I had a lot of dad jokes yesterday. I had to ride in the car with my kid for like 4 hours. So today is pandas. All right. So out in week 5, you will have this recording. And then we'll have another project this week and another little mini quiz. But the first thing we're going to talk about is pandas. So if you come out here to this pandas link, we're going to talk about the pandas package, which you guys used a little bit of that last week, right? So when you did the Yahoo Finance stuff, you got back this data frame, and then you had to take this nice, cute data frame that worked really, really well, and then strip it back down to simple lists and plot that out, right? And many of you sent me a message like, can I just leave it in the data frame? No, that was the whole point, right? We wanted to see what it's like to work with basic list data and then work into what an actual data frame is, which is pandas. And now the ease and the use and the flexibility of what you can do with those as data frames makes it much, much easier to work with. So when you guys got back that information, if you'll remember right, you got things like the adjusted close date, the open, all the different pricing for all the different stocks that you were looking for, and then all the different dates associated with that. With pandas, it's meant to be a fast, flexible, and expressive data structure designed to work with relational and labeled data and be both easy and intuitive. And it is pretty darn simple. So it aims to be fundamental high block for doing practical real-world data analysis within Python. And additionally, it's got the goal of becoming the most powerful, flexible open source computational tool. All right. So things that are meant for pandas are going to be tabular data, excuse me, with the heterogeneously typed columns. What's that? It's basically SQL data, or think of an Excel spreadsheet, right? You got all your headers across the top, you got all your data down below. We can work with that kind of data. We can also work with ordered and unordered data, so it's not necessarily fixed at a frequency in a time series set of data. So time series type of data is going to be something like the stock information we are working with, right? It's at a specific date and time. We have a bunch of statistics going along with that specific point in time. So for example, when we downloaded that data, if I recall, the default frequency was like every minute or every 2 minutes or 5 minutes. You can set those increments all the way through there. It will work with arbitrary matrix data, so homogeneously typed or heterogeneously typed with row and column labels. It also works with any other form of observational statistic data sets, and that data does not need to be labeled at all to be placed into a pandas data structure. So we can work with just straight numbers, basically, if we wanted to. All right. In pandas, there's 2 different primary data structures. You're going to have what's called a series, which is the 1-dimensional, and you'll have a data frame, which is 2-dimensional. And those will handle a vast majority of use cases for finance, statistics, social science, many things within engineering, right? For you guys that are using R, it's going to provide everything that's in R's data.frame and much more within Python. So that's a reason you'll start to see a bleed between those 2 languages, Python and R, particularly when you're dealing with strong data science or data analysis. All right. Pandas is built on top of NumPy, and it's intended to be integrated well within the scientific community environment. So as we start looking down, there's a couple of things that Pandas does well. It will work with missing data. So if there's no data showing up, it will be represented as NaN, or capital N, lowercase a, capital N. and that's in a floating point as well as non-floating point data. You can insert columns, delete columns from within the data frame in higher dimensional objects. Obviously you guys can read this chart as well. I'm just thinking of things that, if I recall, are going to be on the quiz. So for the quiz and such, know this overview of what Pandas is, understand what's the key series within it. One of the cool things about Pandas is that it has robust IO tools, meaning that we can store our data in several different ways. So we can put it out as CSV files, we can put it out as comma delimited files, Excel files directly, databases directly, or we can save and load the data in a specific format called HDF5. All right. And that one's like super fast data format for dealing with this kind of stuff. It does have time series functionality, meaning that we can do date range generation, frequency conversion, moving window statistics, date shifting, lagging, a bunch of other cool stuff. All right. So Pandas is fast. It's easy to work with. Key things you want to know is that there's two different data structures. You have one-dimensional series, two-dimensional data frame. All right. Everybody get the difference between that? Okay. And then it's going to get into some basics. So to get started with Pandas, if we click over here on this Get Started tutorial, again, the documentation, I could build out a bunch of PowerPoints, a bunch of cool stuff. The documentation is really, really good. And that's why I like Python in general. Most people write really good documentation for the data frames. So if we come out here and click on what kind of data does Pandas handle, we can import Pandas. So if I fire up my pie chart, so in this case, I got to get my virtual machine fired back up, then I can get it started. Again, that's the reason I'm shifting around the syllabus. All three of these weeks build on each other. So we go from the initial part where you guys learn how to plot things, how to work with that kind of time series data, NumPy, SciPy. Then we get into where you're actually dealing with the data frames and how much nicer it is to deal with those. And then we move from there all the way into Streamlit, which is a way to visualize this much more effectively in a web app fashion. Get this up. Okay. Get all the way in there. Okay. So this was our project from last week. If we come in and create a new project, and we will start with just pure Python's fine. Now you can either play with this or you can call it your Pi mini project 2, and you can just start working along. Now I don't have the stuff out there for 2. We will see that when we get out there. This particular environment, we're not going to use Conda. We'll just go back to virtual BNB and we'll create a new one. That all looks good. Let's create that window. Remember, you can go out to GitHub, create your project there, then download it, bring it into PyCharm, or you can go the other direction, right? We can create our project, push it on up to GitHub. And I'm going to try to get everybody's homework stuff graded this weekend. I am taking a group of students to Kansas City this weekend for a conference. So hopefully on Sunday, I'll be able to catch everybody up. Okay, so we'll just get our initial main screen here. We can ignore that. And we can get started. So to get started in Pandas, first thing we got to do is install Pandas. So if we come over here, we type in Pandas, click on that and install. I noticed a lot of you went in that first project, you got your graph showing and stuff like that, right? And then you went back and started adding all the extra labels and datas and all that kind of stuff and plotting. So that will lend you greatly to this week when you guys really start dealing with the data frames and being able to use the labels that are already in the data frame, right? And then you can send it out the right way. So like I said, the more effort you guys put in the little mini projects, much easier your capstone or the final project in this class is going to be. Explore the documentation, figure out how you can make it neat and show it off. All right, Pandas. So obviously, remember when you install packages, it's got a bunch of dependencies. What's one dependency of Pandas?
NumPy.
NumPy, right? So good answer. So, and if we recall, when installing NumPy, there was a ton of other dependencies for NumPy. So it's going to take a little bit to get it up here. Make sure you guys are still building your requirements files and things like that in your project. That's going to become real important next week when we start dealing with Streamlit. Because we will have a way of actually running a one-liner and it will automatically generate a web app and spit it out and build a cool dashboard for all the stuff that you guys are playing with this week. So, okay. So we got Pandas installed, and if we come out here to the Python console, which hopefully actually works this time like it's intended to. There we go. And so if we import Pandas as PD. Now, PD or import Pandas as PD, that's one of those that's like an industry standard. So much like you probably saw if you took the quiz, if I ask you for different ways on the way you're supposed to import Pandas, it's typically done as import Pandas as PD. All right. And so once we get it imported, then the easy way to do this is you'll typically see DF, and that's going to be equal to the data frame that comes in here, right? So if we take this little chunk of data and we paste this into here, we have DF and then equals our pd.dataframe. So we're using our dataframe module from the Pandas data set there, or the dataframe class. And then we are passing in a dictionary as a whole as to all the information that we want within that data frame. So you'll notice we pass in a dictionary. Then for each key value, we have a list. And in this case, that list is going to be some names. We're going to have the age of these individual people, and we're going to have their sex that goes through there, right? So we get that in, we hit enter. Notice because we're dealing in PyCharm, we can click over here and we can see all this information and a bunch of extra things that you guys will see here that immediately pop up with this data frame. So not only do we have the age, the name, and the sex, we also have a bunch of other attributes that comes in there. For example, if we look at our df.age, we're going to see nothing comes back, right? Because we didn't type in capital A since we had it through there. So df, and in this case, we're going to do age. And you can see we get all the ages back out of there. We can see that we not only get the ages out of here, notice that it does 0, 1, 2 on the side, that we also are getting the data type, in this case, integer 64s that come back out of there, right? Lots of other things. So if we do df.columns, you will see, oh, I'm sorry, just df.columns. There we go. We can get a list-like object back of all the different columns that we have there. For example, name, age, and sex. We can grab back different rows. We can grab back indexes where things start. So lots of things are associated with the data frame that comes all the way through there. All right. If we just type in df, we will actually get it to spit out to the console in the form of a data frame down here. It's usually pretty clean. So if we bounce out of this here and I go back and copy this information, we put this into our file up here. And again, if we run this file, nothing should happen, right? Because we need to print df. So if we print df and then run it, a lot of times you'll get this data frame back like this. Okay. Pretty basic, pretty straightforward. However, we can deal with the different information. So like this tutorial is telling you, you can pull out the columns, we could save things out as a spreadsheet, and we can deal with a bunch of different information inside of there. So if we type in the age, you will get back series information. This is what's known as a single dimension, right? We pull out the tag, we get all the information that comes back out of that. That comes out as series information out of our main data frame. All right. You can set up individual series. So if you want to create that series from scratch, you can create something like ages and do pd.series instead of data frame, and then pass in the list of the values and then the tag or the name that we're going to create there as well. And that will create the same information coming out. All right. What's nice about this, again, because we can calculate things with NumPy, because Pandas is built off NumPy, we can go in and immediately pull things out like this series here and find out the max age that's inside of there. Or maybe we want to just type in ages.max if we're dealing with the series information. So if we go back to our Yahoo Finance and we pull all that information out, we can immediately find out what the highest closing price was just by typing in max off the highest closing column, right? Real quick, easy to grab information outside of there. If we do something like describe, it's going to tell us all this information, basic statistic data that you guys may be doing in research. So if you're doing research in your final project and you need to get, how many there are, count, the mean, the average, the statistics of 25%, 50%, 75, etc. You can get all this information really, really fast in here. All right. You can read and write tabular data. So if we have our import here, we can read from a CSV file. So if we create a CSV file or an Excel file, we can do things with HTML, JSON. We can pull all sorts of information in, read it into a tabular format, and then we can spit it back out as a different format. A lot of times where I've used this is I'll read in CSV files, massage it with Python, or maybe I'm reading this information out of JSON. If I've got some API that's spitting back information to me, basically what Yahoo Finance does as a JSON file, we dealt with that. We can then massage that, put it the way we want it, spit it out as a PDF file, spit it out as an HTML file. We can make it nice and neat inside of there. So here you can see, in this case, the quote Titanic that's reading from this particular CSV file. It can import, excuse me, all the indexes over here, and it will have all the passenger IDs, how many survived, etc., all this different statistical information. All right. If we want just the first 8 rows, we can use .head. Now, many of you must know, know that concept of head out of Linux, right? You have head, and then what's if we want the last 8 out of the table? Tail, right? No different than we used in Linux. So we have head, and we can use tail in order to pull the last ones. We can use Excel. So if we want to output things to an Excel sheet, it's just as simple as taking our data frame. For example, we have our data frame here, right? This simple little data frame. We can say df.to Excel, right? Then we pass in the data frame or the information that we want. So in the Excel writer, we look at this simple spreadsheet. We tell it which one we want. Let's paste this in here. We can say go out to, and in this case, we're not going to do Titanic. We're actually going to do our team, for example. We have a sheet here that's going to show our passengers. That's the sheet name that we're going to create. Index, we don't want to actually index off any specific one. And if we simply hit enter and then run this file, oh yeah, we got to put in OpenPyXL. So in this case, we have to have a package called OpenPyXL. And so we go out to our Python packages and OpenPyXL. There we go. And OpenPyXL, many of you guys use this a little bit in INF601 when you guys were dealing with the smaller class, if you wanted to deal with Excel files. If you want to deal specifically with Excel files, OpenPyXL is probably the best package. There's a lot of packages out there. If you're just dealing with CSV files, you can deal with the built-in CSV module that's in Python. You can just import CSV at that point. All right, so with this in here, we will now need to import OpenPyXL. And so now if we run this, you will see it finished. And all of a sudden over here on the left-hand side, we have our team Excel file. And if we double click on that, yeah. So because I'm in my virtual machine, I don't have Office installed, but it would go ahead and pull up in Excel and be able to pull it from there. Okay. And we'd be able to see that kind of content come out. You could set where you read it into an Excel and you can pull that in there. So if you want to pull specifically from the passenger sheet, you can pull that information into Titanic and then pull the head information and get that out there as well. If you do info, you're going to get all the information of that particular column, including the data types that are in there, whether they're floats, integers, etc. So it's really slick to pull a bunch of information out of there. If you want to pull just a subset of data out, for example, we want to pull all the ages out and then we just pull ahead of that. We can pull that information. You can do type, you can do shape on the output, which will allow you to build and form little mini data tables outside of there as well. Now, the one that really matters is going out here to plots. So if you remember when we installed matplotlib and we did plot, we can come out here and simply pull some information out. And in this case, all we have to do is just type whatever that data frame is and do .plot. And if we do .plt.show, it will immediately show it in a really cool chart. Right? So it's much easier to use because there is a plotting function built into Pandas, and therefore you can kind of plot that out and use that with matplotlib. And I think many of you basically did this. You just had to trim it out and put it in a list, right? And then on your plot show, you had to pass in the different labels and how that all worked inside of there. All right. You can do scatter plots for something like this, where you're just doing plot.scatter. You could build out plot boxes like these. For example, these would be, it's showing data frames as a plot box, but this box method is also typically used in finance. So if you're dealing with open close statements and you're dealing with the spread that's going between there, you can typically build this out. In finance, they typically call it candle plots going through there. All right. So again, over here on the left-hand side, you can find some really quick tutorials on how you want to shape your statistics, how you can combine data from multiple different tables. And then if you go up here to the user guide, you're going to see how you can be able to read this stuff in. Very specifically, what I wanted you to see was the API reference. And if you come out here, actually, let's pull this back. Right here on IO tools. And actually, if you do this 10 minutes, it's going to show you exactly how to build this stuff out. You can do intro here, and it's going to show you how to build everything out, just like we already did with statistics. It's really this IO tools that I want you to be the most familiar with. So when dealing with CSVs, you're going to use the read CSV and to CSV for writing it out. And you can deal with all these different syntaxes that are out here. And a lot of you, when you're dealing with statistical information, are going to use things like SPSS. You may use things like the HDF5 thing. Remember that the fastest one here is going to be HDF5, right? That's the fastest format going out. These are all binary formats, just like Excel and Open Document and those in here. And then you could actually go to SQL if you wanted to write it out to like a SQL database. Okay. So know this one out of everything that you're going to learn over here on the left-hand side. IO tools should be the first one that you guys will go around and play with. Try to spit things out to a CSV file, read it in. Try to spit things out to an Excel file and read it in. Those are the kind of things that we're going to do in our homework project or the mini project this week. Other things you can deal with on the left-hand side here, you can see what it's like working with text data. So there may be things that you want to statistically pull out, or the data type you can set to D strings. You can work with missing data. Remember that it sets it as NaN. Hint, that'll be on the quiz. Any values that are missing in there, it just fills it out as NaN inside the chart. So for example, if we're missing these indexes, you can see that it just puts NaN all the way across here if they're missing. Let's see. The other things I wanted you guys to be familiar with was chart visualizations. Again, this is how you can plot things out very basically. You could do table visualizations. This is how you can spit things out in a nice little table. You can also do this so that you can see something like regressive formats. You can use the formatter in order to format this so that it aligns the way you want it to. This is a horrible output, but it looks much better on the command line. And so this is nice. I've used this in when I pulled statistics for like students that are inside my cybersecurity classes and they do labs on our platform. If I need to pull out how many labs they did, but how much time they spent on it, that kind of stuff, I actually use an API to go into the system, pull it out in the format, data frame, and then I can spit that out to a PDF document and bill off the students for doing that kind of stuff. So it works really slick, and you guys will use it in a much basic format. Time series data. If you want to put things to a data time, you will use what's called time series, and you can generate those and spit that out in here. All right. The other thing I wanted to demonstrate to you guys is something that's not necessarily with Pandas, but it is a package called Faker. And the reason I want you guys to deal with this one is you're going to use this in the any project to generate data. So we use this in cybersecurity sometimes when we need to generate fake data. So if we come in here and come into our packages and we import Faker, import this in. This Faker package is going to allow you to generate a ton of different fake data. And there's a bunch of different fake data that you can generate. So it's a great way to dump a bunch of stuff in a database or practice making these charts and datas and Plotly and that kind of stuff. This is a great way to create a bunch of random data that goes inside of there. All right. So with this Faker project, if we come back out and look at the documentation, we simply pip install Faker, or we can use the PyCharm section that we're doing. And then at its most basic level, pull this out of here. We will import Faker from Faker. Notice this is a lowercase Faker. And then we will say something like fake, or we can do fake data, makes it a little easier to understand, equals Faker, right? And now if we say something like fake underscore data dot name, and we run this, of course, we need to print that in order to see it. Like that. We run print. And we'll get back some fake name out of there, right? What's nice about this is we can use this to generate a lot of fake names. We could use it to generate all sorts of different data that's inside of there. So for example, let me grab this here. You can use it to create even fake addresses. You can pass in generalizations. So like if you want it to be in the US, if you want it to generate a fake address in the UK, there are obviously different formats and setups. You can have it generate fake text. What's slick, so like say here for the for loop, you can simply do this and create 10 fake names. So if I do for I basically in range, in this case, we're just going to print the actual names, and it should spit out 10 names for us. Fake is not, oh, it's because I changed this from fake to fake data. So there we go. And you can see it just spits out randomly 10 different names. So seems pretty basic, but it's really handy when you're trying to build out websites, generate fake data in there. You don't have to sit there and think in your head, how am I going to do this, right? You say, okay, you have a company of 100 people, which means you need to create 100 fake names. You need to build out full profiles for them. And so to build out full profiles, you can use things like providers, and that will allow them to create different properties and different information inside of there. So if you come out here to grab our profile section, which is probably the best one. You can also seed the generator that's coming in. So for example, if we do faker.seed and then you just type in a random number, from there on out, the names it generates and things are going to be in a different list. So if you're trying to create randomness inside of there, you can pass in random seed numbers and it will go ahead and help with that as well. Or if you want a specific instance, you can go back to a specific instance. All right. Let's see. What I wanted to show you was generating specific profiles. Here we are. And so building in specific profiles, if we come back here to our fake and say we build 5 of these and we use profile and hit play, we're going to generate not just names, but we're actually generating their jobs, the company they work for, social security numbers, what their residence is, where they're located, their current physical location. We can see that in latitude, longitude, what blood group they are, what website they are associated with, a username, name, password, just a ton of data, right? And the idea is that we can generate this data real fast. Now we can put this data into something like a data frame, right? And so if you guys are trying to generate and play with data frames, you can generate a bunch of data right on the fly. And you can build out entire personas on here. Now, I know some of your wheels are turning, right? This is really fun to generate fake websites. If you want to generate fake emails and stuff that we do in cybersecurity, this faker stuff works really slick, right? Anybody have any questions on this faker package? I encourage you to go out and play with the different providers that are out there. What we built there, excuse me, was the full-blown profile. You can also build out things like a simple profile, which will just give you a much smaller subset of fake information. You can see over here on the left that something like a profile is generating essentially all of these different providers, right? Different bank accounts that you can sort information in there. You can build out credit card numbers, right? And then you pass in which type of credit card that you want. So a MasterCard, make sure it validates to a MasterCard number. You can generate all this kind of stuff. Yes. So I said, once people get in there and start playing, they're like, I can build some cool stuff in here. Yes, you can. You can build expiration dates on those credit cards. You can build all sorts of random information inside of it. What's that? Well, randomish information, right? So you're random building stuff, and sometimes it may work, sometimes it may not. I don't know. I didn't tell you that. Stop the recording, right? All right. So yes, come out here, play with the faker. That is what's built into the standard provider package. There's also what's called community providers. This allows you to use things that other people have added in. So what's cool is you can add like air travel and it will pull in a bunch of airport names and airport codes, and you can build out entire flight itineraries, fake itineraries, right? So exactly. So all of a sudden everybody's wheels are turning. You can generate a lot of data with this thing. You could build out credit scores, fake data credit scores, so you could turn them into your bank and do it. Again, I'm not teaching you how to do this stuff, but at one point I probably should have faked my credit score because it wasn't the greatest. Since fixed that. But anyway, lots of good community providers out there. I've done this to generate fake ESSIDs. So Wi-Fi, when we're talking about, again, on the cybersecurity side, if I want to generate a bunch of fake SSIDs and then I actually broadcast them out with my controller, it makes it look like there's 20, APs sitting out here on this thing. If I name them all different, then I can hide my one that I want to be in the network, and everybody's trying to take down all the fake ones when I have my main one up and running. Lots of cool things that we try to do in teaching it. So again, really cool information. You can generalize and you can fake this kind of stuff out. Let's see, local providers. You can do this where it's local to the individual code. So what that means is in the US, you're going to have a bunch of providers specific to that. We scroll down here to US, wherever that one went, that one's hiding. But these are all local. So if you want to generate specific things from Russia, for example, you can generate all the information that's associated with Russia. Lots of cool stuff that you can write in there. Okay. So I want you to kind of come in here and kind of play with Baker to generate a bunch of information. And then you're going to use that to build out different data frames, right? And as you generate that information into data frames, then you guys are going to use Plotly and some other stuff in order to graph that information out. You can still go back and use things like the Yahoo Finance if you want to use finance information and build stock tickers and stuff. But for this project, when I send up the stuff, you're primarily going to be using Pandas frames. You're going to be generating all of the describe information. So give me the max, the min, the averages, all that kind of stuff out of the fake data that you generated. Everybody kind of understand what the tie is between the two? All right. So how about my online guys? You guys understand what's going on?
Yeah, I'm good.
Sam, Crush. Okay. All right. So that's what I have today. I wanted to introduce those packages, let you guys kind of play with them a little bit here for the rest of the class period. On Thursday, when we come in, I'll have the homework assignment, or basically the mini project, and all of the outlines. It's going to be just like the first one. Did everybody kind of understand how the requirements and stuff work on the first project? It's pretty straightforward. Again, if you haven't posted those out to GitHub, post those out there so that I can go through and grade those this weekend. And really try to have fun with this part. And the reason I say that is next week when we start dealing with visualizations for this, if you generated a bunch of cool data or something like that this week, it will make next week a whole lot more fun when you're trying to build a web app for it, right? You're welcome to go to any API and grab data. So I showed you Y Finance. I've showed you Faker, where you can just fake a bunch of data if you want to. But you could also go out and gather other API. So say you want to go out to the US Census and grab a bunch of statistical information from Ellis County, right? So how would we go get that information? Well, let's go look. Simple Google search will help us in there. So let's pull this down. So we want US Census, and let's see if there's an API associated with that. There you go. Available APIs for the US Census Bureau. Perfect. And so if we come in here, there's obviously a bunch of different information we can pull out. Let's see if we can find something of interest here. Microdata. Where was microdata? You're talking like economic indicators? Oh, economic data. Is that what you said? All right. So there's our economic data, right? Let's go see what we can pull. All right. Let's see. There we go. Here's an API that pulls this in. Let's see here. That's one way to do it. Most of these return like JSON data, and that's what I'm looking for, because then you guys can put that into stuff really slick and easy. Let's see, key goes in there. Used to be able to pull out a whole lot better data than that.
How about data like from data.gov?
From where?
Data.gov.
Data.gov.
Mm-hmm.
See what we got. Okay, yeah. You got an example of something you want to pull there, Sam?
No, not particularly.
Let's see what kind of topics we got. Let's look.
For example, they have so they aggregate U.S. federal agencies open data into this site. So, for example, from FCC, we can pull in broadband subscriber information over different geographies.
Okay. So let's see, FCC you said?
Right. So for example, we can pull, say, in Kansas, everybody who's got download speed over, say, 10
Gotcha.
megs or, stuff like that. But pulling the data is something I haven't, like I've done this manually through the web interface, but hooking into specific APIs, I have not done that.
Gotcha. Let's see what we can pull here. So we can narrow that down a little bit. What are we on here? Well, if we had an example data set here, it'd be a little easier.
So I put a search query in the chat.
In the chat.
Yeah. That's weird. That should
Which one
bring-
did this pull back from?
It should bring one data set. That data set should link to this. So this is where the data is coming from, the FCC. I can put another link.
Okay. Let's pull that up over here. So this is a good example of stuff that I'm looking for in this week's project is you just go out, find a data set. If you can't find something that you specifically have an interest in, then go generate fake data for all I care, as long as you pull that out. So here's a good example, right? This is going to be the API of all this information of provided tables, which basically is a summary data of fixed coverage by the geographic area. We get it in JSON, and you can see all the different columns that are in this data type, different populations, things that we want to pull out. Here's kind of a table preview of the numbers that we're going to come in. We can obviously create a virtualization. They have all this built into this website, right? It's kind of slick in order for us to build and see this data pop out in different charts and do that kind of stuff. That's essentially what we're going to be building next week. We're going to build our own way of doing this kind of stuff with this data. So if we look at this API and we throw this in here, which was the JSON link, I believe. Yes. And so this gets us all of our statistical information and pull that down. So we can do this one in two ways. We can save this JSON data out, or we can use it to retrieve it inside of our project. So say we do something like import requests. Right. And import JSON. And we'll have to install requests. Requests is what we're going to use to actually pull from that URL. So instead of having to download the JSON data to a JSON file, we could actually use the URL that will then download that data for us. Right. So inside here, we can do something like data equals requests dot get, and then we pass in that format, which needs to be inside quotes. that. And we don't have any kind of auth or anything, so we can hit that. If we go to data.status code and we print that out, again, when you're first playing with this kind of stuff, it's really slick to do that in the Python console because let's start this one over. Stop it. There we go. Restart. Because then you can play with this data on the fly and then kind of build out your project up above. So if we look at our data status code, we should get back 200 there. There we go. We got a 200. Remember, 200 when we're doing HTML stuff is good. That means we got data back. So if we want to look and see what our data is, right, we can pull the different headers and the type that's in there. Let's see, is it text? Is that no .json? There we go. So I'll pull this back up, go to my Python console, and if I do data.json, you're going to see we got all that data back, right? So now that we have JSON data inside of there, and we're going to just stick this over here. So we could say my JSON equals data.json. That will get us back there. And then if you remember inside of our pandas, go back to our pandas documentation, this one here. And we go back to our IO tools. We want to read things in from JSON. So we simply use read JSON. We can either read it in from a file or from a buffer. In this case, we're going to just read it in from the buffer. You can also pass in URLs. So we can do URLs directly into Python Dataframes, and we can send that in there. Let's see, for URLs, the host is expected, so instance, local file could be something like that. Okay, so what we can do is go back to our file. I did it the long way around, but you could use requests, or we could simply do something like df equals pd.dataframe dot here. Frame. We could just pass in the JSON, that'll work. So we could say df equals pd.readJSON, and instead of JSON in here, we could actually just pass in this URL. Right. And then we can see if our PDF is working. So if we just print df there, again, we will comment this out for now. So there we go. Comment with a line comment and then run. You can see that we got all that information now out of the JSON. And so now because we got it in a data frame, we can get all the information that we may want to get out of this data. So something like df.describe. If we print something like that out, you can see that we can get the mean values that come out of there, the statistics, the max, and all that kind of stuff out of there. So you can use the request to get this information and massage it if you want to use JSON, but Pandas actually has that built in. So therefore, we don't actually need any of that. We can just use straight Pandas to pull that data down. Right. So obviously, you're going to have to go through here and figure out exactly how you want to use this data, how you would have to, pull that out. If you come back here on their website, they could tell you what these values mean and how this information shows is relevant inside of there. Anybody have any questions on working with different APIs and such? So try to do that. Try to go out here, grab some open data. You can generate the fake data if you want to, if that's more fun. Doesn't matter to me how you want to do it. But be familiar with that so that when we come in on Thursday, you guys are able to play with these back and forth. And then we'll have the project outside of there. All right, Sam, Kush, you guys got any questions?
Nope.
I'm good, yeah.
Go ahead and stop the recording.